Hello my dear wonderful genius students, I'm back again with a new video. This is lecture number 7 on complex analysis. Today I'm going to solve some numerical problems. The problem is determine whether the following functions are analytic or not. Students, in my last video I had already mentioned you how to determine whether a function is analytic or not. In that video I told you that to determine whether a function is analytic or not, we have to check two conditions. First condition is known as the necessary condition, and according to necessary condition, del u by del x should be equal to del v by del y, and del u by del y should be equal to minus del v by del x. And this necessary condition is also known as the Cauchy-Riemann equations. And the second condition is known as the sufficient condition, and according to sufficient condition, all the partial derivatives, that means del u by del x, del u by del y, del v by del x and del v by del y should be continuous functions of x and y. Now let us solve these problems. So according to first problem, f of z equal to e to the power x into cos y plus iota sin y. So given f of z is equal to e to the power x into cos y plus iota sin y. Now let us simplify. After simplifying, we can write f of z is equal to e to the power x cos y plus iota sin iota into e to the power x sin y. So here the real part of f of z is e to the power x cos y, and imaginary part of f of z is e to the power x sin y. So therefore u is equal to e to the power x into cos y. So this is the real part of f of z, and the imaginary part of f of z is equal to e to the power x sin y. Now let us calculate del u by del x and del u by del y. So del u by del x is equal to e to the power x cos y, and del u by del y is equal to minus e to the power x sin y. Next let us calculate del v by del x and del v by del y. So here del v by del x is equal to e to the power x into sin y, and del v by del y is equal to e to the power x into cos y. So here we have seen that del u by del x is equal to del v by del y, and del u by del y is equal to minus del v by del x. That means the given function f of z satisfies CR equations. And apart from that, we have also noticed that all the partial derivatives, that means del u by del x, del u by del y, del v by del x and del v by del y are continuous functions of x and y. So finally we can conclude that the given function f of z is an analytic function. Now let me write those parts. We have seen that del u by del x is equal to del v by del y, and del u by del y is equal to minus del v by del x. So the given function f of z is equal to e to the power x into cos x plus iota cos y plus iota sin y satisfies CR equations. Also we have noticed that we have noticed that all the partial derivatives that is del u by del x comma del u by del y comma del v by del x and del v by del y are continuous functions of x and y. Hence, the given function f of z is equal to e to the power x into cos y plus iota sin y is analytic function. Now let us solve the second problem. So according to second problem, the real part of f of z is 3x square plus 4y square and the imaginary part of f of z is 3y square x plus 3y. That means here u is equal to 3x square plus 4y square and v, that means the imaginary part of f of z is 3y square x plus 3y. Now let us calculate del u by del x and del u by del y. So that means here del u by del x is equal to 6x and del u by del y is equal to 8y. Now let us calculate del v by del x and del v by del y. So here del v by del x is equal to 3y square and del v by del y is equal to 6xy plus 3. Here we have seen that del u by del x is not equal to del v by del y and del u by del y is not equal to minus del v by del x. That means the given function does not satisfy Cauchy-Riemann equations. Hence, we can conclude that this function is not an analytic function. So, we have seen that del u by del x is not equal to del v by del y and del u by del y is not equal to minus del v by del x. Hence, the given function f of z is equal to 3x square plus 4y square plus iota 3y square x plus 3y is not analytic. Now let us solve the last problem. So according to last problem, f of z equal to 1 by z. Here we have seen that f of z is not given in terms of x and y. So first our task is to represent f of z in terms of x and y. So let us do. So given f of z is equal to 1 by z. We know that in Cartesian form this z is written as x plus iota y. So first replace z by x plus iota y. X plus iota y. Now let us multiply numerator and denominator by x minus iota y. x minus iota y divided by x plus iota y into x minus iota y. A plus b into a minus b formula. So, a square minus b square. So, after simplifying we can write x divided by x square plus y square minus iota into y divided by x square plus y square. So, we have seen that the real part of f of z is x divided by x square plus y square, and imaginary part of f of z is minus y divided by x square plus y square. So, therefore, u is equal to x divided by x square plus y square, and imaginary part v is equal to minus y divided by x square plus y square. Now, let us calculate del u by del x and del u by del y. So, therefore, del u by del x is equal to, for calculation of del u by del x, we have to apply this formula. We assume that f is a function of x and y and z is a function of x and y. So, del x of f by z is equal to z into del f by del x minus f into del z by del x divided by z square. So, in our case f is x and z is x square plus y square. So, after applying this formula we can write x square plus y square whole square. So, x square plus y square, del x of x value is 1 minus x into del x of x square plus y square. So, after simplifying we will get twice x. Now, let us further simplify. So, if we simplify, then we will get y square minus x square divided by x square plus y square whole square. Again, del u by del y will be equal to x square plus y square whole square, x square plus y square into 0, because del y of x will be equal to 0 minus x into del y of x square plus y square. So, after simplifying we will get twice y. Next, let us further simplify. If we simplify, we will get del u by del y as minus twice xy divided by x square plus y square whole square. Now, let us find out del v by del x and del v by del y. So, here del v by del x will be equal to twice xy divided by x square plus y square whole square. Please try to solve this part by yourself. Again, we can find out del v by del y will be equal to y square minus x square divided by x square plus y square whole square. So, here we have seen that del u by del x is equal to del v by del y, and del u by del y is equal to minus del v by del x. Hence, this function satisfies CR equations. And apart from that, we have seen that all the partial derivatives are continuous functions of x and y except at x equal to 0 and y equal to 0. That means the given function is an analytic function at every point except at x equal to 0 and y equal to 0. Okay? Now let us write those parts. So we have seen that we have seen that del u by del x is equal to del v by del y, and del u by del y is equal to minus del v by del x. So the given function f of z is equal to 1 by z satisfies CR equations. Also we have noticed that all the partial derivatives that is del u by del x, comma del u by del y, comma del v by del x and del v by del y are continuous functions of x and y except at x equal to 0 and y equal to 0. So we can conclude that the given function f of z is equal to 1 by z is analytic at all points except at 0, 0. So this is all about today's video, and I hope that you will be able to determine whether a function is analytic or not by using CR equations.